All right, welcome back everybody. Before we actually start concept 22 using the discriminant, I want you to just take a look at this problem right here. Suppose I gave you the problem x squared plus 5x plus 3, and suppose I just gave you the tiles, which would be these tiles. And so there we go. In order to factor or find out what the factors were using tiles, I would need to be able to create a rectangle with these guys. So if you played around with this, you might find that we're going to have some trouble with this, because if I took this guy right here, if I took that guy and I put it here, and then I try to put my 3 1s in, well, I have a problem because I still have this guy. That's kind of in the way. I would need to put a 1 there. Well, I could try to put it here. If I put it down here, well, that doesn't help me at all anyway, because then now I've got to put 3 more 1s there. So if you take it doesn't matter how much I play around with this, it's not factorable. So this problem right here is a problem that we actually can't factor it. It doesn't have a GCF, and we can't factor it into binomials. Now, it's a pretty simple problem. We might find that we don't always have problems that we're going to know immediately if they're factorable or not, which is why we need this next concept, which is using the discriminant. So I want you to stop the video right now, and I want you to read the paper until you get to it says this, the formula for the discriminant is. So go ahead, stop the video, and read up to this portion. So basically, to sum up what you read, pretty much not all polynomials can be factored, right? We learned that if a polynomial has 2 terms, the only way it can be factored into 2 sets of parentheses filled with binomials is if it's a perfect square minus a perfect square. If you have 3 terms, we now know, well, you might be able to factor it into binomials, and then we'll talk more later about 3 if you have more than 3 terms. So right now we're just focusing on 2 terms and 3 terms. Now, there's a formula called the discriminant, and this formula you're going to see many times throughout the year, but it's b squared minus 4ac. And this is the formula that we're going to use to determine whether or not something is factorable. Okay, so let's start first about what the heck is a, b, and c. So put a big star by this section right here. A is always the coefficient of x squared, b is always the coefficient of x, and c is always the constant. And remember, coefficients don't include the variables, they just include the numbers. So let's go ahead and take a look at number 1. Number 1 up here says 4x squared minus 4x plus 1. So if I were to decide what's a, what's b, and what's c, well, the coefficient of x squared is 4. So a would be 4. The coefficient of x is negative 4. So that would be b. And my constant in the problem is 1. Okay? Number 2, well, a is the coefficient of x squared. And since there's not a number in front of x squared, we would imagine there's a 1 there. So a is 1. B is going to be the coefficient of x, which is negative 5. And c is my constant, which is negative 6. Now be careful on number 3. Number 3, I did put it to you out of order. So if you have one like this, well, we would put it in the right order, but right now it's not necessary. There's the x squared term. That would mean that the coefficient of x squared is 2. So that would be a is 2. B in this case is 1, because that's the number that would go in front of the x term. And c is negative 6, the constant. Now in number 4, we're missing a term. But what term are we missing? Well, we're missing the x term. So the coefficient of x in this case, that would mean that the x is canceled out, which means the coefficient was 0. So b would be 0. So in this case, a is 9, b is 0, and c is negative 49. Now, what in the world does this mean? Well, what you would do is you would plug the numbers for a, b, and c into the formula, and here you go. If you plug it into the formula and the answer that you get is a perfect square, then the polynomial can be factored. If it's not a perfect square, then we would say that this polynomial is not factorable. So let's go ahead and take the problem that you did earlier, x squared plus 5x plus 3, and let's use the discriminant. So in this case, we're going to say that a is equal to 1, b is equal to 5, and c is equal to 3. Now the formula is b squared minus 4ac. we're just going to evaluate this formula by plugging 1 in for A, 5 in for B, C in for 3 in for C. So let's go ahead and do that. So I'm going to do B squared, so that's 5 squared minus 4 times 1 times 3. And remember, the order of operations says that I've got to do my exponents first. So I'm going to do 5 squared is 25. Then I'm going to do my multiplication and division. We can do this at the same time. 4 times 1 times 3 is 12. We are subtracting 12. And 25 minus 12 is 13. And this number is called the discriminant. That's the value of the discriminant. Is that number a perfect square? No. So that means that that guy is not factorable. And we would just move on. All right, so let's try a few more together. Let's look at number 1. Remember that A is the coefficient of x squared, B is the coefficient of x, and C is the constant. This problem is out of order. Now, because we might end up factoring this problem, you should rewrite the problem so it's in order. So in this case, the problem should be written 2x squared plus 5x minus 4, which means now A is 2, B is 5, C is negative 4. And now we're going to plug it into the formula. B squared minus 4AC. And since B is 5, I'm going to do 5 squared minus 4 times A is 2, times C is negative 4. So now order of operations says I have to do 5 squared first, which is 25. So I'm going to have 25 minus 4 times 2 times negative 4. Then I have to multiply. And now when you go to multiply, notice there's a minus sign and there's a negative sign. So right here, that's a minus sign, and this is a negative 4. Now we could do 4 times 2 times negative 4 and get negative 32 here, but then it would be 25 minus negative 32. Or we could look at this 4 like it's a negative 4, but you have to realize that still we're going to either add or subtract here. So notice this is, we could say negative 4 times 2 times another negative 4, and since it's a negative times a negative, that becomes a positive. So we're going to have here 25 plus 32, which gives me 57. And since 57 is not a perfect square, we're going to say the discriminant is 57, we have to say that this polynomial is not factorable. All right, let's look at number 2. Number 2, notice you only have a coefficient of x squared, and then you have a constant. So automatically we should know that A is going to be 25, because that's the coefficient of x squared, and C is going to be negative 16. Now, because we don't have an x term, we say then that the b value is 0. And so I'm going to put it into b squared minus 4ac. So I'm going to say b is 0, so it's 0 squared minus 4 times a is 25, times negative 16. And now 0 squared is just 0, so I have 0 minus 4 times 25 times negative 16. And again, when I go to multiply all of this together, use that like it's a negative 4. So it's going to be like 0 plus, and it ends up becoming plus because I'm doing negative times a negative, which is a positive. And 4 times 25 is 100, and 100 times 16 is 1600. So it's 0 plus 1600, which just leaves me with 1600. Now 1600 is a perfect square. Since this is a perfect square, we know that this polynomial right here is factorable. So if this is a perfect square, then we are actually going to try to factor 25x squared minus 16. Now many of you probably knew this was factorable before we started because it's a perfect square minus a perfect square. Remember, when you have a binomial, you really can only factor it if it's a perfect square minus a perfect square, and it factors into a difference of squares. So we're going to break up 25x squared into 5x times 5x and negative 16 into positive 4, and negative 4. And reminder, the inners here give me 20x. The outers give me negative 20x, which do give me 0, which is the middle term. And so there's my factorable polynomial. All right, feel free to stop the video and try 3 and 4 on your own, but I'm going to go ahead and explain these two anyway. So number 3 is in the correct order. A is 1, B is 6, and C is 9. Take it into the formula. B squared is going to be 6 squared minus 4 times A is 1 times C is 9. Square your 6, so I get 36, minus 4 times 1 times 9 is 36, so I have 36 minus 36, which is 0. Now, is 0 a perfect square? The answer to that is yes, right? The square root of 0 is equal to 0, so this is yes, it's a perfect square, okay? So that thing can be factored. So this guy right here can be factored, so we are going to factor it. So I'm going to take my two sets of parentheses, break up x squared into x and x, and then I'm going to break up 9. Factors of 9 are 3 and 3, 9 and 1. Well, we're trying to get 6x in the middle, so the only way to do that is to do plus 3 and plus 3, which we could say is x plus 3 squared. And there you go. Okay, now let's try number 4. Number 4, pay attention, it's not in the correct order. So I've got to put 4x squared first, minus 2x, plus 5. Okay, so now A is 4, B is negative 2, C is 5. So now let's use the discriminant. Now be careful, B is negative. Remember, whenever we square a negative, we have to put it in parentheses. So I'm going to have negative 2 squared minus 4 times 4 times 5. So that's negative b, or b squared minus 4ac. So be careful. Negative 2 squared is positive 4. B squared, after you square it, will never, ever, ever, ever be negative. So be careful about that. And then you multiply 4 times 5, which is 80. So I have 4 minus 80. And 4 minus 80 is negative 76. And negative 76 is not a perfect square. So we would say that this polynomial is prime. And when I say this polynomial, I'm talking about this guy right here. That is prime. We cannot factor that into binomials. All right, so we haven't talked yet about what happens when there's a GCF. A polynomial that has a GCF, and this is written right here, a polynomial that has a GCF is said to be factorable, but you can use the discriminant to determine if you can factor it further. Meaning, if it's a trinomial or a binomial, can it be factored further? And the way to check that is to use our discriminant. Now, you can find the discriminant before or after you take out the GCF. However, if you take the GCF out first, you're going to have smaller numbers to work with, which is always easier. So my recommendation is always pull out your GCF first, because if you forget to pull out your GCF first, then you might find that if you use the discriminant and you find out it's not factorable into binomials, then you might forget to go back and pull out your GCF, and then you're going to say it's prime. So it's not prime if it has a GCF, okay? So let me just show you how I would do this problem. The very first thing I would do is look at my problem and say, is there a GCF? And in this case, there is a GCF. I can pull out a 12, okay? So now, because I can pull out a 12, we can't say that this guy is prime, okay? But I'm going to pull out the 12, and I'm going to get x squared plus 5x plus 4. And so now, because what I have left here is a trinomial, this could possibly be factored further. Now, a lot of you might look at it right now and know whether or not it can be factored. However, sometimes we don't know. So what we could do now is we take this. We're checking to see, can this be factored? So I'm going to take this and plug that into the discriminant. So in this case, A is going to be 1, B is 5, and C is 4. And so I'm going to do B squared. Well, that's 5. 5 squared is 25. Minus 4 times 1, because that's A, times C is 4. And so we multiply. 4 times 1 times 4 is 16, so I get 25 minus 16, which is equal to 9. And 9 is a perfect square. And so what that tells us is that this x squared plus 5x plus 4 can get factored into binomials. The 12 is still a factor. Don't forget it. Bring that 12 down. And then I'm going to break up the x squared into x and x. The 4 can be broken up into 4 and 1. That's the only way to get 5 in the middle. Okay? So this would be my answer. Now, if you found the discriminant of this before you pulled out the 12, you still would have gotten a perfect square. It just would have been a very large perfect square. And so then you would go back and factor it. But don't forget about your GCFs. That's one of the biggest mistakes that we make. So now when you get your homework tonight, you're going to need to follow these directions. So notice my directions up here. A, take out a GCF if there is one. If there isn't one, we're going to go over to B and then find this. Then find the value of the discriminant. Once we do this, so you're going to do B for every single problem. You're only going to do A for problems that have GCFs. Okay, so I want you to go in this order, A, B, C. And then once you find the discriminant, then finally factor into binomials if possible. So we're going to do that over here. So let me show you what I mean. So step 1, take out the GCF first. So yes, there's a GCF in this one. It's 2. So we're going to pull out the 2, and we're going to be left with x squared minus 7x plus 10. And then I'm going to find my discriminant. So I'm going to say that A is 1, B is negative 7, C is 10. And I'm going to start plugging stuff into my discriminant. So I'm going to do negative 7 squared. Don't forget, negative 7 has to go in parentheses, minus 4 times 1 times 10. Now, negative 7 squared is positive 49. Now, if you wanted to square that first and just write down 49 minus 4 times 1 times 10, that's safe, okay? Then I'm going to do 4 times 1 times 10 is 40, so I'm going to do 49 minus 40, which is going to give me 9. So there's my discriminant. This is a perfect square, so that means that I can factor this further. So I'm going to go back over here, and now I'm doing step C, factor if possible. So the 2 is still there, and then I'm going to break the x squared into x and x, and then 10, I can do 10 and 1, or I can do 5 and 2. My signs have to be the same because the last term is positive, so they're both going to be negative, negative, because I'm trying to get negative 7x in the middle. I'm going to break that into 5 and 2. And just a reminder, because I haven't been doing very good reminders, my inners here become negative 5x, my outers become negative 2x, and that does give me negative 7x. And then it's the 2 that gets distributed back into this that brings me to 2x squared minus 14x plus 20. All right, let's go ahead and try number 8 together, and then I'm going to let you finish this paper on your own. So start, take out a GCF first. If there is one, there might not always be one, but this one has one. So I'm going to pull out the 5. And when I pull out the 5, I'm going to be left with 12x squared minus 5x minus 3. Okay? So now I'm going to go over here, and I'm going to find the discriminant. I'm only going to find the discriminant of the trinomial that's inside the parentheses. So A, in this case, is 12. B is going to be negative 5. And C is going to be negative 3. So I'm going to do b squared, so that's negative 5 in parentheses squared minus 4 times 12 times negative 3. And so then I'm going to square negative 5, so that's 25 minus 4 times 12 times negative 3 is negative 144. But because it's minus a negative, that's going to give me plus a positive. So it's going to be plus 144. And then if I add those together, I'm going to get 169. Is 169 a perfect square? Yes, it is. So that means this guy can get factored further. So I'm going to have a 5 on the outside of parentheses, and then let's start trying to break up the 12x. Go ahead and stop the video and see if you can factor this one on your own, and then come back and see if you've got it right. So I found 12x can be broken up into 4x and 3x. My signs have to be different because I've got a negative 3 at the end. If I put a 3 in the first set of parentheses, that's going to give me an inside of 9x. And if I put a 1 here, that's going to give me an outside of 4x. Now keep in mind, I'm trying to get negative 5 in the middle. If I make this a negative 9x, that means that I put the minus sign here and the plus sign here. And then I get negative 5x in the middle. So this is fully factored. Now stop the video and try the next set of problems on your own, and then come back and check to see if you are correct. Okay, so take a look at these answers here and check to see if you did them right. Notice I didn't write not factorable on any of them because they all have GCFs. And so if something has a GCF, technically it's factorable. So like we had to stop, right? So if you take a look at the first one, my GCF was 14. And then what this right here, this negative 8 means, that means that I can't factor this trinomial further. So I just circled this as my final factored answer. Over here, however, my GCF was 10x. Notice in my final answer, I brought the 10x down. It's part of my answer. And then this 256, because that's a perfect square, that means that this trinomial right here can be factored. And this is what this can be factored into. And then here, I pulled out a 3, and then I found the discriminant for this part right here, which is 57. And because 57 is not a perfect square, then I can't take this further. So my final answer is this. So the other thing I want to point out to you is over here, if you look at what this says, it says when the directions say factor, you can assume that all the problems are factorable, that it's possible to factor into binomials. However, when the directions say factor if possible, you have to use the discriminant to determine if it is factorable. So today, on your homework, most problems will say factor if possible. So if it says factor if possible, before you even start the problem, you follow these steps. Pull out the GCF, find the discriminant, and see if it's factorable. All right? So please make sure that if you don't understand anything, that you are getting help as soon as possible. Good luck.